4.1, and finally we're getting into the periodic table and atoms and what you might consider to be the actual chemistry, although what we've learned so far has also been the actual chemistry, but now we're going to get a little bit more specific with regard to the elements. So the first thing we need to discuss is what an atom actually looks like. Now you guys might have seen the Jimmy Neutron sort of thing that might look like this, right? And you've got this right there, something that looks like that. Now that's valid too, and that's a different type of model called the Bohr model, and we'll get into that later. But if you wanted to actually graphically or visually rather think about what an atom actually looks like, it would look something similar to this right here. And this is the this model came about later on. This is the quantum mechanical model of the atom. And inside this, if you look very carefully, you'll see a nucleus. And inside that nucleus, you're going to have a proton. And where's the proton? It's inside the nucleus. In nucleus. And the symbol for a proton is P with a positive sign because protons have a charge of +1. Okay, so the symbol, we put a positive sign next to P for proton and a positive sign to indicate a charge of +1. The mass of a proton is very, very, very small. An individual proton is 1.6 times 10 to the negative 24 grams. So that's a very, very small number. And to make that, because it's kind of a clunky number, there's 23 zeros. It's a 0.0023 and then 16. And because that's such a clunky number, scientists have renamed that 1 AMU for atomic mass unit. 1 AMU. Okay, and the size of a proton is 10 to the negative 15 meters, so it's very tiny. A neutron also makes up the nucleus, and its symbol is N for neutron, and it doesn't have a charge, so we put a 0 there. Okay, so N to the 0. Well, that's not really to the 0. That's the charge that represents. That's the symbol that represents the charge, which is it's neutral. Okay, it's got a neutral charge, and it is also, it has the same mass, relatively speaking, as a proton. 1.6 times 10 to the negative 24 grams, and we also say that it has 1 AMU of mass, atomic mass units, and the size. So again, these two particles are both, they're similar in size, and they're also similar in mass. The only difference between a proton and a neutron is one has a charge, the other is neutral. An electron is outside the nucleus. Okay, electrons are found outside the nucleus, and their symbol is E for electron, and they have a negative charge of -1. Okay, indicated by this negative symbol there. The mass of an electron, what we can say, it's very, very, we could just say it's massless. Massless. Compared to the proton, which is 1 AMU, an electron, we could say, is massless. What is the mass of an electron? It's 0.00055 AMUs. Okay, because it has such a small mass, 0.0005 AMUs, we can just say that effectively it is massless. The next part, how big is an atom? There's a video here, and if you would like to, and I'm going to encourage you to just go ahead and watch that video. You can pause this video and watch that video and then come back. Okay, so at this point you should have watched that video, and we can fill in some of these blanks. If an atom were the size of a blueberry, there would be enough atoms in a grapefruit the size of the Earth. The Earth. So in other words, if you had an atom the size of a blueberry, there would be enough atoms in a grapefruit the size of the Earth. So what that's saying is, if you took a grapefruit and you blew each of the atoms up inside a grapefruit to the size of a blueberry, how big would that be? Well, it would fill the entire Earth. Okay, so that's how many atoms are in a grapefruit. If an atom were the size of a football stadium, the nucleus would be the size of a marble. So if you took one atom and blew it up to the size of a football stadium, let's say the Rose Bowl, the nucleus, if you went to look for the nucleus, you'd have to look down there on the field, and it would be the size of a marble. Between the nucleus and the electrons, there is empty space. Empty space. The density of the nucleus is like putting 6.2 billion cars in a 1 cubic foot box. Yeah, in fact, we were talking about earlier in the year, we were talking about what is the most dense material. And well, the density of a nucleus, the density of an atomic nucleus is probably the most dense material, I would suspect, in the known universe. In fact, neutron stars are based on this principle here, that nuclei of atoms are very dense, and when they compact on one another, when they collapse on each other, you get a very dense material. Anyway, yeah, that's the density of a nucleus is like putting 6.2 billion cars in a 1 cubic foot box. So let's look at another model of the atom. In this graph here, we have proton, neutron, electron, and then the atom. We have the actual size. Okay, that's the actual size. If we had the model size of 10 centimeters, it would be an orange. Okay, if we had a neutron also the same size, the model would be 10 centimeters, and it might be the size of an apple. Okay, so then how big would an electron be? Well, based on this size now, we're saying that the proton in this model is 10 centimeters, roughly the size of an apple. The neutron also 10 centimeters, roughly the size of an apple or an orange. So then how long would the electron, how big would the electron be? Well, it would be 0.1 millimeters. 0.1 millimeters, maybe a speck of dust, right? Just a speck. And if we were to use this scale to represent these atoms, so in other words, a 10 centimeter proton, a 10 centimeter neutron, how far away would the electron be from this nucleus? Okay, let's say the nucleus was the size of an orange and an apple together. How far away would this 1 millimeter speck be from the nucleus? It would be roughly 6 miles away. 6 miles away. Okay, so what we're trying to impress upon you then is that the nucleus of the atom is, the electron is very, very, very far away from the nucleus of the atom in scale. Okay, if you were to blow that atom up to the point where the nucleus is the size of an apple and an orange, that electron would be very, very far away, 6 miles away. Okay, the atom's mass is due to its protons and neutrons. No apostrophe there. Its protons and neutrons. The mass of the atom is in the protons and the neutrons in the nucleus. The atom's volume is due to its electron cloud. Okay, and this would be considered the electron cloud right there. So again, that would be the nucleus, and this is the electron cloud. Okay, so the atom's volume is due to the electron cloud. The mass of the atom, all of the mass of the atom, is present in this little teeny tiny nucleus. I'm going to go ahead and end video 1 here.